I have to remember to do that. Okay, so if you have your x and your y-axis, and if you have a graph that kind of has that shape, the answer f of x equals x to the third. Or if you have one this shape, kind of like that, that's your f of x equals square root of x. So those are kind of the foundation of everything we're going to kind of go over, at least for this section today. All right. Anyone still? I'll leave it up there for a little while. Make sure everyone got it. Bless you. All right. Okay, so we'll start with vertical. Graph shifts. Okay, so the first one, a function f of x will shift c units up. That's just if c is a number. When you have some function h of x, which equals your f of x plus c. Okay. Now that same function will shift c units down. When it's written as h of x equals f of x minus c. Okay, so let's say, for example, if you wanted to graph let's say f of x equals x squared minus 3. Okay. So the first thing you want to do is find your what they call the parent function. And you find your parent function by getting rid of all of the numbers, except your exponents. Just the negative 3, you just drop it. And that would give you your parent function. So find your parent function by removing all constants. Okay, so you do not remove exponents. So if you have f of x equals x squared minus 3, then you remove that minus 3. So that would just leave you with f of x equals x squared. Okay, so this is your parent function, which means that's where everything's going to start, just with x squared. Okay, so we're going to graph f of x equals x squared, which looks somewhat like that. Oh, move that up a little bit. Okay. Now, since we know x squared minus 3, we'll shift it 3 units down just by the explanation up here. So if you have f of x minus c, so this f of x is our x squared, minus 3 would mean it would shift c units downward. So you have your x, you have your y. Kind of draw a dotted outline of x squared. Oh, that turned out horrible. Okay, so if it shifts 3 units down, that means this whole graph, just almost like you just pick it up and move it down 3. So this would be f of x equals x squared minus 3. So shift 3 units down. Okay. Excuse my graphing drawing, but hopefully you get the general idea. All right. Any questions on this one? All right. Leave that up for a few seconds. All right, let's go to the next example. Okay, so let's say, for example, we wanted to graph f of x equals absolute value of x plus 4. Remember, the first thing you want to do is find your parent function. So f of x equals absolute value of x plus 4. If you remove that, then f of x equals absolute value of x is your parent function. Which means everything we do is going to start with that one. Okay, so you have your x, you have your y. Remember, absolute value of x just kind of looks like a v. So we know because of that plus 4, we're going to shift it 4 units up. So if you have your x and we have our y, we kind of separate that a little bit, made it a little too close. Okay, so this is our f of x equals absolute value of x. I'll just kind of draw a dotted outline there. If we shift it 4 units up, let's say this is 1, 2, 3, 4, and I should have really made that lower. Sorry about that. Actually, let me just remove that for now, and I'll write that above it. So you keep one of these when you know you mess up a lot and have to write in pen. Okay, so this is your parent function. Okay, so absolute, let me clear that a little bit more. There we go. That's good enough. Okay, so that absolute value of x, the whole thing just shifts right up. So now it will look like that. And that's your f of x equals absolute value of x plus 4. You just got the whole thing and moved it up 4. So if that would have been minus 4, we would have just got the whole thing and moved it down 4. Okay, so I'll do one more. So let's say if we wanted to graph f of x equals square root of x plus, I'll pick it and say plus 2. Okay, so if we have our f of x equals square root of x plus 2, then we're going to remove everything except exponents, all the numbers, which means that f of x equals square root of x is our parent function. Okay, so if we graph our square root of x, okay, we have our x and we have our y, and we know this is our square root of x, kind of looks like that. Okay. Now if we have square root of x plus 2, we're going to move that whole function up 2 spaces. Yep, make sure I have room that. Yeah, got enough room. So x, here our y, and I'll do a dotted drawing of square root of x. So our square root of x plus 2, just get that whole thing and shift it up. So this is our f of x equals square root of x plus 2. All right, and then we'll work the same way with f of x equals x, f of x equals any x squared, x cubed. It would all do the same thing. If it's plus some number, you'll move it up. If it's minus some number, you'll move it down. All right. So any questions on this one? Okay, so those are all of our vertical shifts. Now we're going to do our horizontal shifts. Oh, I'll leave that up in case we're still writing. right. So, get some more paper. Okay, so now we're going to get our horizontal graph shifts. Excuse me. Okay. So first, f of x will shift c units to the right when h of x equals f of x minus c. And that's the one thing about horizontal. If it's minus, it's going to shift to the right. If it's plus, it's going to shift to the left. So f of x will shift c units to the left when h of x, oh, sorry, I wrote that incorrectly, f of x plus c. The x minus c should have been inside the parentheses. Sorry about that. We'll give that one more once over. X minus c. Okay. So an example of f of x plus c, x minus c, before we start graphing, I'll just kind of give an idea of how it will look. So if f of x equals x squared, then f of x minus 3 would be x minus 3 squared. Or if you have f of x equals absolute value of x, then f of x plus 8 would equal absolute value of x plus 8. Okay. So whenever you have the x plus or x minus, this is where it would shift either to the left or to the right. In this case, it would shift to the right. In this case, it would shift to the left. So this would shift right 3 spaces. And this would shift left 8 spaces. Now, it's a little confusing because you would think with the minus it would shift left, but with horizontal it's the opposite. All right, so let's do a few examples. Of actual shifting. Okay, so for example, let's say we wanted to graph f of x equals x minus 4 squared. Okay, so you can tell just by the setup that it's going to shift 4 units to the right. Okay, but if we have f of x equals x minus 4 squared, you want to get rid of every number that's not an exponent. So you're going to remove that minus 4. And that leaves us with f of x equals x squared, which is our parent function. Okay, so that's the function everything is going to start from. So if we graph That's our x, that's our y. And we know our x squared looks something like that, give or take. So that's f of x equals x squared. Okay. So we know and make sure I have enough room. That's our x, and that's our y. And if we have our that's f of x equals x squared, you're going to shift this 1, 2, 3, 4. 4 units to the right. So this is f of x equals x minus 4 squared. Okay. Which makes sense because if you plug in x equals 4, that would be equals 0 squared, which would be 0. So that would be y equals 0, and it goes from there. Uh-oh, straighten that up a little bit. All right. Does that make sense? All right, so let's do one more horizontal graph. So that was a minus. I'll do a plus one on the next. Oh, I'll leave that up for a second. All right. Okay, so let's say, for example, you wanted to graph f of x equals pick a square root of x plus 3. It's starting to run out a little bit. Okay, so we know if we have our f of x equals square root of x plus 3, if we get rid of all of our non-exponent constants, that means we're going to get rid of that plus 3. Which leaves us with f of x equals square root of 3. Oh, sorry about that. Square root of x. Which is our parent function. Okay, so that's where everything's going to start from. Okay, so we get our graph. And we have our x and we have our y. And we know that our f of x equals square root of x looks something like that. So we have our x and we have our y, and we have our outline of where our parent function was. So we know since it's plus 3, we're going to shift it 3 units to the left. So -1, -2, -3. Okay. Should have moved that over, but. Okay, so this one is our f of x equals square root of x. All right. So any questions on that one? All right. Give me a second to finish writing that out. Okay. Now we're going to look at reflections in the coordinate axis. Okay. And all that means is that if you see a negative in front of it, it just flips. It flips across the x-axis. So when h of x equals negative f of x, the graph is reflected across the x-axis. And 2, when h of x equals f of negative x, the graph is reflected across the y-axis. And reflected means just that. It's almost like you're looking at a mirror image of it. So it just depends on if you're looking at a mirror image across the x-axis from top to bottom, or a mirror image across the y-axis from side to side. Okay, so let's say, for example, if we wanted to graph f of x equals negative x squared. Okay. Now f of x equals negative x squared is the same as saying f of x equals negative 1 times x squared. Okay, so we want to remove all constants that aren't exponents, which gives you f of x equals x squared as your parent function. All right, so if we have our x and our y, our parent function is f of x equals x squared. So we know that's going to look something like that. So f of x equals x squared. Okay. Now negative, you put a negative on both sides, you have negative f of x equals negative x squared, then that's going to reflect across the x-axis. Okay, so if we kind of give a dotted, straighten that up a little bit.